seat in a vehicle must be set up for each individual driver using that seat. We are used to finding seat adjustment controls in cars, so controls such as fore-aft, headrest height, seat base angle and backrest angle are familiar to us all. When we adjust the seat, we need to consider both comfort and our body size. We have to make sure that we can sit comfortably, we have good clear vision to the outside of the cab, and that we can see and reach all necessary controls within the cab without twisting or overstretching. One control that is not found in cars is the adjustment for driver weight. This control makes sure that the seat suspension is set to the middle of its operating range, preventing the suspension hitting either top or bottom end stops when the vehicle goes over a bump. The control can either be mechanical or, as we have here, electrical. In either case, check the adjustment by bouncing on the seat to make sure that it moves freely and it is close to the middle of its travel range when your weight is on the seat. The seat suspension is essentially a mass spring system. At low frequencies, the vibration is unchanged by the suspension. As the frequency is increased, we find the suspension's natural frequency, or the resonant frequency. The suspension seat is amplifying the vibration. When the frequency is increased above the natural frequency, the suspension absorbs the vibrations and the seat movement is reduced. We need to make sure the seat's natural frequency is below the vehicle's own natural frequency. Otherwise, our seat suspension can actually make vibration worse. Or, at lower frequencies, make little difference, passing all vibrations straight through to the driver. Now, if we repeat this test and focus on the driver, at low frequencies we have transmission of the vibration. The seat base and the seat pan move up and down together. When we are close to the seat's natural frequency, the vibration is amplified, so the seat suspension is actually amplifying vibration. Look at how far the driver's shoulders are moving. The seat moves less than the simple spring demonstration because dampers in the seat suspension restrain the vibration. The dampers must be working properly to prevent excessive amplification. Ideally, we want the seat to be operating above its natural frequency, where we get effective vibration reduction. When specifying a seat suspension, we need to make sure its natural frequency is below the vehicle's own natural frequency. A vehicle will have its own natural frequency due to tyres and vehicle suspension. It is the frequency at which the whole vehicle wants to oscillate and can be observed when a vehicle goes over a bump.